On today's flipped classroom video, I want you to create a foldable on the real number system. By learning the real number system families, you will be able to describe the difference of rational and irrational numbers and identify different types of rational numbers. At this time, I need you to get the supplies together that you will need to make this foldable. You will need a piece of paper, scissors, and a pencil. So if you need to pause the video at this time to collect your supplies, please do that. Also, when this foldable is complete, you will be able to add it to your journal. If you don't have your journal at home, just bring it to class, and the next time you're in class, we will add it to your journal. So first I need you to turn the paper this way. And I want you to fold it lengthwise to make a hot dog. Now we need to divide this section into 6 equal parts. So first I want you, let's turn it this way and fold the paper down in half again. And the difficult part is dividing this into thirds. So what you want to kind of do is roll it like a burrito until you've got your 3 sections, and then just squish it down. So when you open it up, you should see that you have 6 sections. And I like to show my students what the end result will be so they kind of know where we're headed. So this is what we're going to be making today, and you'll be able to open the windows and see each of your real number families written here. So now we're going to cut the windows open. So you only cut to the halfway point. So go ahead and cut your 6 windows. And we're ready to begin. So our first window is going to be labeled natural numbers. And then I want you to draw an arrow pointing down this way. Okay, then we're going to open up the window, and this section right here will be the definition, and then over on the left-hand side we'll give examples. So your natural numbers, you're going to write a counting number, 1, 2, 3, 4, and so on. A counting number, 1, 2, 3, 4, and so on. And then over on this side, we're going to give examples. I'm just going to put EX for example. So some examples of counting numbers would be 4, 123, and maybe 5. So I would like for you to add a 4th example at this point. And when you get back to class, we will share the different examples that you came up with on your own. Okay, our next window is whole numbers. Okay, and an arrow pointing down. And you might be wondering why I'm putting these arrows here. Well, I'm putting those arrows there because all natural numbers can fit into the family of whole numbers. So our definition for whole numbers is a member of the set of positive integers and 0. A member of the set of positive integers and 0. So some examples of whole numbers would be 4, or we want to add the 0 because that's the only difference between your whole numbers and your natural numbers is the number 0. So 4, 0, and maybe I'll put something in there that you wouldn't think of, like 5 squared. Because when you simplify 5 squared, you would have 25, and 25 would be a part of the whole number family. So now I would like for you to add your own whole number at this point. Okay, our third window is integer. Okay, with the arrow pointing down. Because so far we have that our natural numbers can be also a whole number, and our whole numbers can also be integers. So integers are a whole number, either positive, negative, or 0. A whole number either positive, negative, or 0. And an important thing to remember on integers is that they have to be whole numbers to be an integer. So some examples of integers, we can now use our negative symbols. We can have like negative 16. We could have 5. And then maybe something that you might not think of would be, for example, 12 over 4. Because 12 over 4 simplifies to 3. So 3 is a whole number. So at this time, if you'll go ahead and in this section add another integer example. Okay, our next window is rational numbers. Okay, and on rational numbers, we're going to put that arrow pointing with a circle around it and the little knot, because at this point we stop. So natural numbers can be whole numbers can be integers, and then the integers can also fit in the family of rational numbers. So our rational numbers, now this one is the most writing you're going to do, so you might have to write kind of small inside of this one. This is a set of integers as well as numbers that can be written as proper or improper fractions. The decimal form of these numbers repeat or terminate. So this one's kind of long. The set of integers as well as numbers that can be written as proper or improper fractions. The decimal form repeats or terminates. Okay, so some examples would be -5, 12, and then maybe something that you might not think of, for example, 1/3. Now you can't, you might not know for sure if this 1/3 is rational or not until you change it to its decimal form. But when you change 1/3 to its decimal form, you're going to get a repeating 3. And because it repeats, it therefore fits the definition of a rational number. So if you go ahead and add a 4th rational number to your examples. Okay, then we have our irrational numbers. Okay, and your irrational numbers, they are the set of numbers that can be written as decimals but not as fractions. set of numbers that can be written as a decimal, but not as fractions. Okay, so these are numbers that they're irrational. They don't repeat. They don't have a pattern to them. So they're very sporadic type of numbers. So it might be, for example, a really long decimal number that never repeats or never has a pattern to it. So it just keeps going and going. So we call that irrational. Or if you were to find the square root of 5, you would find that that number is irrational. And then one of the most famous irrational numbers, as we use a symbol to describe that number, and that is the number pi. So at this time, if you will go ahead and add a fourth example of an irrational number. Okay, and then last we have the real number system. Your real numbers. And this one includes this group of numbers includes any rational or irrational number. So we can look back at all the previous windows, okay, and we can pick numbers from any of these windows to add in this group down here, because they are included in the real number system. So I can put, our examples, I could put a 4, I might put the square root of 5, or maybe the fraction 1/3. So I've got different types of numbers here, so you can go ahead and add a fourth one. See if you can be unique and add something different that we haven't thought about adding before. So tomorrow when you come to class, you need to be able to answer the question, see if you can, or not answer the question, but describe the difference between a rational and an irrational number. See you in class.